good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access it on demand later. We'll be sending out an email post-webinar that will include a link to enable you to access the webinar. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our panelists, please just use your GoToWebinar control panel and submit your question, and we'll take as many questions as we can near the end of today's presentation. And also, before we close out today's webinar, we will be doing a drawing for 3 $50 Amazon gift cards. So stick around, hopefully you'll be one of our 3 big winners. Okay, with that, we'll go ahead and kick off today's webinar, which is securing container-based applications at the speed of DevOps. Our speakers today are Carmen Puccio, who is Principal Solutions Architect at AWS, and Shiri Evsan, who is the Product Manager at WhiteSource. Welcome to you both. Thanks for joining me today.
Thanks for having me.
All right, great. Well, Carmen, I know. Go ahead.
Go for it.
I was just going to put myself on.
I was going to say, with that said, let's just kick it off, right?
All right then.
All right, awesome. So thank you everyone for joining. Again, my name is Carmen Puccio. I'm a Principal Solutions Architect here at AWS. Give a little bit of background about me. I've been with the company for about 3 years now, working with our mass migrations partners, whether they be technology or consulting partners, essentially helping customers transform their workloads and figuring out how to move over at scale. And in the last year, I've taken on a specific focus in the modernization realm. Thinking about how we can enable containers and serverless and essentially take these applications and as part of their move, think about the modernization efforts as well. So I'm going to kind of kick it off, and then I'm going to pass it over to Shiri just to talk about the value out of WhiteSource here. But I want to talk a little bit about some of the things that we're seeing, and I want to give a little bit of an overview about the AWS services that help in this space, right? So the first thing that we're seeing essentially when we talk about modern application development and microservices, we talk about it in this concept of it being a new normal. Where companies are essentially they're facing this trend of going completely digital. So whether it be cloud or mobile or big data or social technologies, it's really impacted the way that organizations are doing application development. And essentially it's a digital disruptor, if you will, and it's forcing these companies to change at an even faster rate, which means that essentially the application leaders in these organizations really have to work to instill a new culture and new processes and new technologies into their organization to essentially make them become a top performing organization. So we talk about modern app dev. We essentially say that we have this need for rapid innovation as part of that story. We truly believe that microservices architectures make applications easier to scale, faster to develop, and they enable innovation and essentially accelerate this time to market for new features. And we talk about, essentially this flywheel effect, if you will, or this innovation flywheel, when it talks about modernizing your application. And, when you modernize your application or your business, essentially you're doing it because you want to drive growth and you want to accelerate your migrations with repeatable processes. And you want to essentially instill patterns, but at the same time, you want to maximize your value as you go through these efforts. Because again, it's about this speed and agility for the business. And when you look at this flywheel, as you see on the screen here, essentially, if you think about it, it's like the faster you as an organization can collect and analyze feedback, the quicker you can react to your customers. And that feedback could be anything. It could be not just, essentially net new features from the business owners. Think about feedback from the security posture. Maybe, as part of, you running inside of, your modern app dev environment, you have to react to a security incident. So you really want to go through this process where you have the ability to take any kind of feedback, feed it back into not just an idea and an experiment, but also think about it, how quickly can you actually remediate things, right? So it's really about putting the patterns and process in place to not just, get software out the door, but to make sure that it goes out the door in a reliable and secure manner. And if you do have to react to an incident, you can do so as quickly as possible. At the same time, too, when we think about this flywheel, we think about it as an opportunity to reduce costs. We believe that the faster that you can experiment on new ideas, you will fail, but at the same time, you learn from your mistakes. And again, to that point before, the quicker you can essentially get that software out the door through the concepts of CI/CD pipelines, you're going to be able to experiment, and you're going to be able to essentially, move your application at a quicker rate and hopefully reduce your costs. And then, when we talk about how do you actually achieve this and what kind of technologies can you take advantage of, we basically say, listen, it starts with the architectural patterns and the operational model and the software delivery that you see here, right? And we think that AWS has helped many of the customers with these changes. But when you think about, essentially, agility and thinking about microservices, it is a natural fit for modern app dev. But at the same time, too, it's not all just serverless, right? A lot of times people think about modern app dev and they think about essentially, that it's, serverless is a way to radically reduce your infrastructure, and you don't have to manage anything at this point, and you're only working on business logic, and that is true. So again, serverless fits into this net new architectural pattern, but at the same time too, another one that we think is a tremendous enabler is containers, and we're going to talk a little bit about that today. But we feel that customers accelerating their application delivery and reducing costs, a very common approach is to leverage containers. So the container story is especially compelling because it allows customers to essentially achieve this level of agility, and they become more cost effective. And it provides this option for customers to deliver applications very, very quickly for development and operations teams who are essentially under pressure to adapt to growing business needs. If you think about, like, businesses know that getting software products and services to market faster essentially translates into gain market share for them. And containers can help enterprises modernize legacy applications. And it can also help them create net new cloud native applications that are meeting that model around scalability and agility. So again, like container frameworks, Docker, it's provided a standardized way to package your applications, including the code, the runtimes, the libraries, and essentially run them across the entire software development lifecycle, regardless of the environment. So the thing that we say at AWS is like, this is our mission. And since 2014, we've released more than 50 new features and services to help developers better create and manage containers. And our goal, or our mission, is to make AWS the best place to build and run your modern applications. So again, it's not just a serverless thing. Serverless is fantastic, but containers is something that is of the utmost importance to us. And we believe that the goal here is to remove the undifferentiated heavy lifting that your teams have to do to get new ideas off the ground and out the door, and make it as easy as possible to optimize your existing application. So again, think back to that flywheel I was showing about before. So when we talk about why enterprises are adopting containers and what are the benefits around it, obviously the piece around it, defined as code or infrastructure as code, and containers packaging your code with all those configuration files and dependencies basically allows you to run consistently in any environment, like I was saying before. But it's also an enabler for microservices. So they provide that process level isolation, and it makes it very easy to break apart and run applications as independent components, right? So when you think about modern app dev and you think about microservices, companies are shifting to cloud native and microservices architectures, and containers are a perfect way to encapsulate these pieces into portable units. It assists with the automated testing and development. So, the way that development teams and the way that operational teams are essentially changing, and they're moving to these agile methods. They're leveraging CI/CD systems, and containers being lightweight and portable are great vessels to essentially wrap code in order to push them through these software release pipelines. From the monitoring perspective, containers provide this process level isolation. And again, you can set the CPU, or you can get to a very granular setting from CPU and memory utilization for better use of your compute resources. And with that said, it's very important to think about your application level monitoring as well, and how you're going to ensure the overall health of your application as your containers go up and down in this dynamic or immutable environment. And then not to be forgotten is security and compliance, right? To be honest with you, we always talk about that being job zero. And security is super important, but because containers help enforce an infrastructure as code mindset into your application lifecycle, another benefit, and it's a tremendous benefit, is the security of the entire thing. So if you think about it, you have the ability to set and version not just the container itself, but you can also work with the packages that make up your application. And you combine this with processes like vulnerability scans of container images, incorporating automated checks into your CI/CD workflow with your security teams and developers. You can really work to ensure that you've met a high level of security for your containerized app. So I want to go over the AWS Container Services landscape and just kind of talk about the value prop of each one, and then we'll get into a little bit more into the WhiteSource. But it was 3 years ago, in I think it was 2014, that we released the Elastic Container Service, or ECS. And ECS lets customers deploy, manage, and scale their container workloads without having to install or operate container management software. And what that essentially means is, like, don't think about running the hard part or the orchestrator. Think about your application, but at the same time too, you're responsible for your worker nodes. And I'll talk about this in a little bit more. But ECS was built with very deep integrations to the rest of the AWS platform. So things like load balancing, security, permissions management, networking, storage, monitoring, that's all there. And it was built for high availability and low latency and high throughput. And this is one of the reasons that ECS is used by our fastest growing startups and our largest enterprises. And it's at this point, it's running tens of millions of applications worldwide. And then in 2015, we released a highly reliable and performant Docker image registry called Amazon Elastic Container Registry, or ECR. And the goal here with the ECR was to enable developers to use the same familiar Docker push-pull APIs to store their container images. And we see this product being highly adopted by our customers, both running containers on AWS and really across any environment. And what we see is ECR is powering an incredible number of container workloads across cloud and on-prem. But we've taken this mission and we've grown it, right? So over the last 12 months, 24 months, we've introduced AWS Fargate. And Fargate allows customers to focus on the application and not necessarily the instance itself. And we'll talk more about that when I dive into Fargate and how that works. And then lastly, in reInvent in 2017, we announced Amazon Elastic Container Service for Kubernetes, or EKS. It's a managed Kubernetes service, and it's been wildly popular, and it allows you to essentially install your own Kubernetes clusters on AWS, but you don't have to worry about the hard part, which is building and running your masters, and we'll talk about that as well. But what we consistently heard from our customers is they want to run Kubernetes because they love that it's highly available and scalable and cost effective, and that there's a very hard part around it, and it's the master nodes. Customers asked us, could we do a forum? And we always take our customers' feedback when we think about a roadmap and building features, and that's one of the main reasons EKS exists today. It's built from unmodified upstream Kubernetes, which allows you to use existing features and plugins and tooling that you may have already built for your cluster. Applications running in Kubernetes environments that are fully compatible, and you can seamlessly move them to your Amazon EKS cluster. So it's been wildly popular, and at the same time, we'll talk a little bit more about it in depth in the upcoming slides. But regardless, we're super excited about the ecosystem of services that are now enabling AWS to be the best place to run containers securely at scale and for production workloads. So kind of some numbers around this. If in the last couple of years we've seen so much growth in this space, you look at a service like ECS, right, or Amazon ECS. Our active users are up by more than 450% since 2016, and we're managing millions of instances each month. And you know, the fact that customers like Expedia and Mapbox are powering, you know, some of their very popular websites is a testament to how great the services are and how reliable the services are. And it's letting customers build their applications at scale. So again, you know, hundreds of millions of containers are being launched every single week on top of AWS. And they're doing it because of things like the deep integration, right? So customers love that AWS Container Services are, you know, bringing that broad set of capabilities for them to build and manage their containerized application. And we want to make it an easy place for them to run containers. So, you know, they love the integration with our various different AWS services, because I've said this before, like when you build a net new application or you migrate an application, you need some of the surrounding constructs. And the fact that the integration points are there is phenomenal. The DevOps workflow, again, you know, we have multiple tools in this space that enables customers to build and package and ship their containers. And then we have the security controls. Again, you know, the fact that we have certifications across these various different industry standards is phenomenal. So if you have compliance needs, you can take advantage of, you know, the services inside of AWS to build a secure and compliant application for your organization. When we talk about the typical use cases and what we're seeing, I'm not going to go through all of them. The one that I like the most, and I think it's probably because of where I came from inside the company, it's the legacy application migration to the cloud. To my point earlier, it's not necessarily just a lift and shift anymore. AWS has, you know, tools like the AWS Server Migration Service, which is a fantastic tool that allows you to pick things up and move it. But you could argue a little bit around the agility after you've moved it. If you go through the efforts of containerizing your application and putting the surrounding constructs like a CI/CD pipeline and putting the hooks and levers in the process of delivering software in an agile manner, we're seeing a lot of customers take that approach as part of their migration to the cloud. Not to say that there's anything necessarily wrong about doing the lift and shift model. It's a tried and true method, but we're seeing more and more customers, especially as the industry and the surrounding, you know, constructs and applications that help support containerized workloads are growing, and they're growing at a fantastic rate. So I love that use case, not to take away from any of the other ones you see here. So I want to dive a little bit into each one of the services, how they work, and we'll kick it over. So the Amazon ECS, to my point before, it's a fully managed container orchestration platform, and it operationalizes your container workload at a very high scale without you having to install any software. It's a multi-tenant service, and you can spin up a large number of clusters and services and tasks underneath. So think about it, you have your Docker containers and you want to run those Docker containers on AWS, and ECS is eliminating that need for you to install your own container orchestration software and manage and scale the virtual machines. Or schedule those containers on the virtual machines. So with, you know, simple API calls, you can stop and start Docker applications, you know, query the state of your application. And again, to my point earlier, access the familiar features of things like IAM roles and security groups and load balancers and so on and so forth. Scheduling and orchestration is a key concept in the containerized world. And in terms of ECS, with the cluster manager, we have a thing called the placement engine, which plays specific roles to help accomplish these tasks, essentially. So the cluster manager manages the overall health of the instances within your cluster, and then you, as the operations team or development teams, are going to set up an auto-scaling group and register your instances with the cluster. ECS is aware of essentially the capacity that you're going to require for your containers, and the placement engine is essentially what's going to enable the advanced techniques on how you want to place your tasks into those instances. So for instance, if you have certain tasks where maybe you want to land into a certain instance type, or maybe you want to start thinking about things like bin packing for cost savings or better economics, this is where the placement engine is going to essentially help you do that. But the thing is like customers were adopting ECS, and we have tremendous numbers around it, but you know, it's still complex, right? They realized that they were ending up managing more than just the containers, and there's all of these additional layers of management where all they wanted to do was think about the app in the container itself. So this is the reason that Fargate exists today, and we consider it a serverless way to run containers on ECS. So, if you want to think about how Fargate works, without Fargate, you have an EC2 instance, and maybe you have something like, in this example, 2 tasks running on it. And what a task is a collection of containers that run together as a unit of your application. So for here, the 2 tasks, you have to manage the underlying instance, and you have to think about the instance OS and the Docker agent and the ECS agent, which is operational overhead, right? And an ECS agent, just in case you're not familiar with it, is an open source agent which is doing the registration of your instance within the cluster itself. So you end up having to patch and update the OS, and you're thinking about the ECS agent, and you're also thinking about scaling the fleet and how do I do optimal utilization. And all of these tasks is adding this layer of management to your application that I was pointing out before. And essentially what happens is you have these layers of management, and this is kind of what it ends up looking like. And you have this completely managed orchestration or container management layer, but you also have these software management layers just to run your application. So again, all you want to do is run your containers, and Fargate is enabling you to do that in this serverless manner, as I was saying before. So if you notice here, there's no 2 levels of management of scale anymore. You're really only defining your application in terms of a task, how the service should scale, and what metrics do you care about, and how many more containers or tasks do you want Fargate to launch. So again, the goal here is a completely managed infrastructure. You're not worrying about that patching or upgrading the instances. You're not worrying about the size of the instance. And again, you're still hitting the thing where it's fully integrated with the AWS ecosystem. So, we've put this investment in making containers the first level primitive on the AWS platform, which means that when it comes to IAM resources or networking or load balancing or integration with things like VPCs, it's all built into ECS and Fargate, and customers can take advantage of that. So again, to my points before around, why customers are adopting these things, they wanted a fully managed service that abstracted the underlying infrastructure. They wanted essentially the ability to develop and deliver new technology products as essentially a differentiator, and they wanted to manage their services to enable them to build without requiring to build things themselves and investing in hiring or training staff. That essentially thinking about, how do I do infrastructure management? Do I have that skill set, right? So Fargate works with ECS, so you can bring your existing code and your applications and you can run them. The deployment model is very, very similar when you're talking about task definitions. They align very nicely. So it's very easy to move to Fargate if you are already an ECS user. To get into Kubernetes, right? I want to make sure we talk about this. The Amazon Elastic Container Service for Kubernetes, or EKS, is essentially making it easy to deploy, manage, and scale containerized applications using Kubernetes on AWS. And the first thing we need to do is just introduce Kubernetes, and I'm sure you've heard of it, but if you haven't, it's a wildly popular open source project, and it's the platform for running microservices at scale, and it can be run anywhere. And it's being an open source container management platform. It's built to help you run your containers at scale, and comes equipped with features and functions to essentially help you build proper distributed applications using 12-factor application patterns. It's hosted by the CNCF, and a number of customers choose to run Kubernetes on Amazon EC2. And because they love the community, they love the tools around Kubernetes, they've made investments built on the APIs, or because they want a tool chain that is essentially just as portable as the containers running underneath. But essentially what we say is where you run Kubernetes matters. So again, we talk about the quality of the cloud platform. So it's not just about EKS. Like, we see a lot of customers running Kubernetes self-managed on top of EC2, and that's great, right? Because again, the customers are perceiving the performance of your application, how quickly new features are introduced, and essentially if your app is down or not, right? So we really want to focus on the cloud platform and essentially make sure it's a great experience for the users, regardless if they're self-managing it themselves or they're running something like EKS. So, given that choice, customers run Kubernetes on AWS. And, In fact, the numbers are very, very impressive. And AWS has the most customers running Kubernetes in the cloud, with 51% of all Kubernetes deployments running on AWS, according to the CNCF today. And that's just a tremendous number at this point. So really quick on the ECS part, and then we'll pass it off. When we talk about ECS and how it works, it is this managed master node, right? And customers still work with the worker nodes, or they build and manage their own worker nodes in their accounts. And with EKS, the complexity of standing up the infrastructure is simplified. So instead of running, like the control plane in your account, you connect to these managed Kubernetes endpoints in AWS. And this endpoint essentially abstracts away the complexity of the control plane, and your worker nodes check into this endpoint, and you can interact with it with tools like kubectl to just carry on your day-to-day tasks like you typically would in the past. And what you're seeing here is essentially, the cluster being hosted by AWS and this managed control plane. You as the operations team, you would think about how I would place my worker nodes inside of the various different availability zones to make sure that your applications and your instances are highly available, taking advantages of things like AWS auto scaling to make sure that if you did have an issue or if you did need to scale, you can do so in a reliable manner. So when we talk about EKS and we talk about the certifications, right? Amazon EKS is certified Kubernetes Conformance. So you can use the existing tooling and plugins from the partners in the Kubernetes community. And applications running on any standard Kubernetes environment are now fully compatible and can be easily migrated to EKS. And customers are using EKS in a lot of interesting ways. And again, the microservices thing is something that's phenomenal, and it's this net new applications that are born in the cloud. And we have many customers at this point that are building things across things, whether it be machine learning or enterprise migrations or even platform as a service. They're really adopting across all of these different principles, if you will, as they adopt EKS and Kubernetes on AWS. So here's the final landscape of what you see. And before I pass it off, I just want to instill one last thing. Security of your application, regardless of which one of these you pick, is really, if you think about it, how can I secure my application, and how am I going to build automation detection through the deployment process? I want to address blind spots. I want to slow down innovation. How am I going to put security knowledge into my DevOps team so they can build secure pipelines? They need to be able to design and automate these processes. So security being paramount in any organization, you need to think about all of the attack areas in a microservices-based architecture and how you're going to protect and audit around them. So with that said, I don't want to take up any more time, and I want to pass that over to Sherry and let her talk a little bit about how she can address this problem for you.
Thank you. Thanks, Carmen. So thanks again for joining. I'm going to discuss the security part, as I mentioned, a little bit more in depth. So if we look at all these services that Carmen just presented to us, ECS, EKS, ECR, Fargate, even serverless, the goal essentially is to have fast and continuous delivery. And sometimes when we think about security, this is the exact opposite. When you think about security, you think about manual, long processes, usually slowing down the entire environment. And that's exactly what I want to break today. So some of the things that we see, again, speeding us up is open source usage. And I think open source in terms of the software world is one of the greatest revolutions. So we mentioned Kubernetes as one of the biggest, but we have a lot more. Essentially, around 97% of the developers today actually rely on open source software almost all the time when developing software. So open source projects are around 80% of the code that's being written today, which is an amazing number. But it's not all good. With that, we also have the security vulnerabilities. So as we understand that open source is good and is helping businesses, the hackers understand this as well. And this is what we're trying to actually solve and help with. So we see vulnerabilities are on the rise. Since 2016, we see them keep going up and up. And if we think about containers specifically, so for example, if I think only about the last 6 months, we have, I can think of maybe 4 or 5 critical vulnerabilities with regards to Docker and Kubernetes. The latest and more famous one probably is runc, which is the underlying runtime of Docker and Kubernetes. So we can't ignore this. If we think about the container lifecycle, we want to build, we want to ship, and we want to run faster. So if I mention build, what I actually mean is CI/CD. So it can be code build, it can be Jenkins, it can be TeamCity, whatever you use to actually build your images. Shipping is more about the registry part, so ECR, for example. And when we speak about running the actual containers, we can think of EKS and Kubernetes. So there is a challenge. The challenge of security specifically is the dynamic nature. So if we think about containers, we think about clusters. Clusters are almost completely immutable. If you launch them with Terraform, so they just come up and then they go down. But even if not, you can think of pods as they auto-scale, they scale up and scale down. And even if I did have a vulnerability in one of my pods, maybe tomorrow it doesn't exist because the pod is not there anymore. So this is a great challenge for security officers and for security people. It's not secure by default. So this is an important note. Kubernetes, for example, didn't have RBAC, role-based access, as a default feature until the latest few versions. If you use a managed service, so it solves that problem because the managed services usually keep you safe. And then we have the last challenge of fast delivery that we just discussed. So we have a few approaches to that. So the first one is not to do nothing, which of course is not the most recommended thing. But we do see a lot of customers or a lot of users are just overwhelmed by security, about the number of vulnerabilities that they see in their projects, that they just prefer to ignore it. Then the next option is manual intervention. You as a DevOps or as a cluster operator, you can manually control this. So everyone who needs to actually deploy something to dev or to production, you can sit next to them and just make sure that nothing bad happens. And this is more like the traditional security teams that we know. And then you can restrict users from actually creating objects. So you can take that for yourself. You can be the bottleneck and just say, okay, I will create all the resources, all the objects, all the pods, and I'll deploy to production because I know how to do it in a secure way. And if we think about it, these two approaches, or even 3 approaches, are the complete contrary to what we want to achieve when we think of Kubernetes and containers in general. So we understand that this is not the best idea. And we already understand that the common way of handling security vulnerabilities is not the best one. So we see that usually when we come to big organizations, security teams are analyzing and prioritizing the vulnerabilities. Now, the way that they actually prioritize the vulnerabilities is interesting because usually they don't do that based on business value. We see users prioritizing vulnerabilities based on whether or not they actually have a fix, based on the date when it was actually released or disclosed. And these two things are definitely not the way to prioritize vulnerabilities. And we'll speak about that more later. Then usually what they'll do is they will either open tickets for developers to actually solve the issues or upgrade versions, or they'll send email, which is the least favorite part, of course. And then, of course, we need to close the loop. So there is the resolution part. So the developer actually releases the fix. This part is also hard because it's really hard to understand, okay, so there is a version that actually solves this vulnerability. How would I know that it's not adding more vulnerabilities or that it has other security problems? So again, we see the common way of handling security vulnerabilities doesn't really fit what we see today. And it's also bringing a lot of tension between the teams. So as we know, developers always want to have the latest features. They always need to release more and to deliver fast. DevOps, again, they want to deliver fast, but they're sort of the bottleneck between security and developers, which makes it a very hard point to be at. And the security people, if something works and this is the process, they don't want to change anything. So again, a very, very challenging situation. So what do we do? I mean, essentially the solution here, as we try to convey it, is actually baking security into the existing workflow. So what this actually means is that I want to have security as contrary to actually slowing me down, I actually need to bake it into the existing workflows. So this is a very important point, but how can I do that? So I'll start with a few questions that may help you understand whether or not you are working as you should, or you have a secure cluster or secure pipeline. So the first one is, do you use a private registry? So the idea of private registry actually is to protect your images. So an image is essentially your code. This is what you're going to deploy to production. And you want to keep that private, of course. If you take images from unknown sources and you don't scan them and you don't make sure that they're secure before doing that, you may be in a very big problem. So even if you use public registries, it's really important to make sure that these public images don't have any known vulnerabilities. And then another important thing is to actually sign the images. So after I scan them versus I scan them and verify that they don't have any known vulnerability, I want to actually make sure that they are digitally signed. And then I will know that nobody modified them before I deploy this to production. The next question is, do you regularly scan your images? And by scanning the images, what I actually mean is check that the images don't have any known CVEs or known security vulnerabilities. And then the last question would be, how quickly can I rebuild image when I have a security issue? How much time does it take me to actually recover from that and have a fix? So these are the main questions, and now let's try to gather everything together. So again, what we speak about is essentially pipeline gates. We want to scan across the entire life cycle. So we have the development part where we actually want the developers to develop in a secure manner. So even when it's only the research stage and they need to choose a new open source to actually use in a new project or a new feature, we want to make sure that they choose this most secure option. So this is in terms of the development part. Then we have the build. So the build, we already discussed Jenkins, code build, code pipeline if you're using it in AWS. So essentially what we do in the build stage is we build the software, and usually we also run functional tests. So in addition to these functional tests, we also want to make sure that we have some security tests. And then if we fail a build based on a functional issue, we also want to fail builds based on security issues. In terms of the container registry, so ECR, for example, but also others, I want to make sure that everything that stays there is protected. So continuously protect my container registry. And then we see production as sort of the final gate. So before production, before I deploy to Kubernetes, this is the final point where I can actually make sure that I'm not vulnerable. Because if I did miss this part, it means that I'm probably in big problem. So let's start with code build, the stage where I actually build my code. So what we want to do is we want to essentially integrate security testing into our build and our CI process. Have our functional tests, have our security tests, and then fail the build if anything goes wrong. This will make sure that in the build stage, I already check for known security vulnerabilities and for other security issues. The next point would be to actually use automated policies to fail builds. So I don't have to fail any build, even if there is a minor security issue. It's all about custom policies that your organization will set. Of course, there are best practices and there are recommendations, but it's up to you to decide what works for you. Of course, you don't have to actually fail the build. You can also have a Slack notification or an email notification whenever a security vulnerability is detected within the build. The next point in the pipeline is the trusted sources or the trusted registry. So if we speak about ECR, we already mentioned that we want to protect our image registry continuously. So this means that any image that somehow got to the image registry has to be scanned as a gate to enter there. And I want to also continuously scan that and make sure that it happens. Then we have the trusted sources. So we want to use private registries. And if we use images from public registries, we want to always make sure that those are digitally signed, so that no one actually modified them after I scan them. So these are very important points. The next thing is when we actually get to the deployment stage. So as I mentioned, this is the final gate. This is the final point where I have to actually start and find the vulnerability. And that's why it's a continuous process. So what I want to do in EKS or in Kubernetes in general is I can use built-in features by Kubernetes to actually block images or pods or resources with security vulnerabilities from entering production. And the great way to actually do that is to use the validating admission controller. So Kubernetes has a built-in option of verifying resources prior to the persistent to etcd. So this is a great point to actually validate and have sort of this final gate to make sure that you're protected. So another important thing is part of this admission controller, as part of managing the application, you want to make sure that the images are digitally signed. So if you sign them in the ECR stage, this should be quite easy. Then the last point probably would be to actually monitor for new vulnerabilities. And the numbers here are quite amazing. So a few new security vulnerabilities are detected each day, and you have to make sure that you're protected quickly, because the exploited code is usually distributed online. So you want to make sure that you scan continuously. So even if you deploy the version with a vulnerability, so for example, the run C vulnerability, you want to make sure that you're fully protected and that you can identify exactly which images are vulnerable. So if we want to discuss a little bit about WhiteSource and about WhiteSource Database, the idea is, of course, security vulnerabilities database that I discussed. So we have few databases of security vulnerabilities, of known security vulnerabilities, and in association with license compliance database, we gather all together and we actually integrate into the existing pipeline. One of the most important things here is the source of truth or the database, because you want to make sure that you have all the data about the vulnerabilities and about the compliance code. So in terms of WhiteSource Core, which is the main product, what we do there is essentially everything that I just discussed. Detection and prioritization to make sure that you prioritize the vulnerabilities in the correct way based on real business impact. Then we have real-time alerts so that you'll know when there is security issues. Automated policy. So we discussed Jenkins or TeamCity or your favorite CI/CD tool. So we have automated policies there and also in ECR to make sure you're fully protected and that you actually make sure that you handle what's important. And then we have, of course, advanced reporting. So with that, it's time for a short demo, and then we'll get into the questions. So if you have any questions already, feel free to actually type them and we'll answer them. So this is the WhiteSource portal. So this is a demo organization that I'm currently showing. What we can see is the security top alerts, and this is for various products. What I want to show you essentially is the ECS cluster. So in the ECS cluster, I already have top 42 security vulnerabilities. So let's wait for this to load. But essentially, what I can see here is the top security vulnerabilities alerts along with the libraries vulnerability. So for each vulnerability, once I log in, I can actually see, let's see it. Demo time. So for each vulnerability, I can actually see the CVE that's actually affecting it. So let's see an example for I just scanned the regular ECS, so my ECS, and then I have the security vulnerabilities. So most of them are actually in the RPM. If I click specifically on security, because I can see here also compliance parts, let's just click on one of these security vulnerabilities. So I can see what's the language, what's the actual library, and then I can see the library's vulnerability. And the top fix is probably what's most important here. So I can see what's the top fix, what other people online suggested, how should I fix my security vulnerability. And we actually discussed before automating remediation. I think Carmen mentioned it earlier. So another important thing is being able to automate the remediation rather than the developers actually going and reading and understanding what are the consequences of each remediation advice. So that's another thing that we offer as part of WhiteSource for developers. So with that, I think it's time for questions.
All right.
Do we have any questions?
We have a lot of questions. So let's go ahead and just dive right on in. The first question is a little long and involved, so bear with me here. How do you recommend customers meet compliance requirements for antivirus at every layer of their tech stack when running Linux, Kubernetes, or Docker environments in AWS? So Carmen, I think this one is for you. There aren't too many commercial solutions that support containers, and the containers themselves are sensitive to scans run on the underlying OS. It can break them. Do you recommend HIDS technologies instead, or the scanning of containers before they are instantiated, or some other solution?
Is that a question for?
I believe it's for you.
It is. Okay. So I mean, so to back up a little bit, I guess the question is around essentially, can I run antivirus on top of my machines, and how should I think about that? I kind of talk about it a little bit. I back up a little bit when we talk about this. So like when we talk about how am I actually building my containers and how am I building the underlying AMIs, right? A lot of times what we're seeing is essentially like customers have a process inside of their organization that makes sure that those AMIs are up to date with the latest and greatest, vulnerability patches, if you will. So imagine if you take something like Amazon, the Amazon ECS AMI or the EKS AMI, which we provide to our customers on, a regular basis, which has, the latest and greatest approved patches on there. At the same time, what we'll see is customers take that and they typically put, their extra secret sauce, if you will, on top of that. We start at that layer and they think about it, do I need to put some sort of layer of antivirus on top of that machine, or do I need to put some sort of, infrastructure management around that machine or configuration management of that machine? And I tend to take that step back and say, you need to think about that machine being an immutable object, just like your containers. So while security is paramount and what's actually happening inside of that machine, I tend to think of it more along the lines of, can you easily take that machine down and then have your pipeline instantiate a net new build with a net new AMI? So customers are taking advantage of things like Packer to essentially build an AMI as part of their pipeline. If you look at the Amazon EKS AMIs that are provided today, we actually provide Packer scripts. So if you don't want to run Amazon Linux and you want to run something like Ubuntu or CentOS, you can actually use those Packer scripts to go build that. So if you do have an incident where you need to think about, oh, I need to get a more recent security update onto that AMI, it's more beneficial to take a step back and thinking about your AMI provisioning process. On top of that, and maybe talk about maybe from the container standpoint and vulnerabilities inside of containers. But that's kind of the the concept of around the primitive of the actual compute instance itself that I tend to talk about.
Okay. All right. Great. Let's see. Sherry has a question for you. How does WhiteSource become aware of new security vulnerabilities, and how frequently does it pull or download new ones?
So that's a great question. Actually, we do it on an hourly basis. So we have automated tools to actually let us know of any new security vulnerability. And in addition to that, we also have a very large research team that finds new vulnerabilities online if the automated process didn't do it well. So in fact, as a matter of hours, we will already know if there is a new security vulnerability and will automatically alert on that, as our users just saw in the latest run C vulnerability, or basically in any other vulnerability that came out in the last few years.
All right, great. Okay, next question. How can you rebuild images with security fixes without understanding if the fix will affect your application functionality?
Yeah, so that's a great question. So essentially, of course, you have to know if it affects your application functionality. But usually what we see with security vulnerability is that you'll have to upgrade the version. So if these are minor versions, probably you won't need a developer actually analyzing everything. And if you have automated tests in place for all the functionality in your application, which is recommended not only for security, you can upgrade minor versions only with automated tests. And that's what we want to achieve, essentially. We don't want developers to invest all of their time in handling and monitoring security vulnerabilities. We want to make sure that this process is as automated as we can.
Excellent. Okay, great. Next question. Let's see. Do you recommend turning off access to Docker Hub or other public repository?
So essentially, it's up to your organization's policy. There is no best practice here because each organization works differently. I'm not against public image registry. I just think that we need to do it in a smart way. So just pulling any image from Docker Hub would be like, finding some sort of removable disk anywhere and just putting it into your computer. So this is not the smart thing to do. But if you understand and you scan the security vulnerabilities before actually pulling the image, then that's okay. Yeah.
Yeah, and I'll tackle onto that, right? Like we've seen that many times, and customers ask that question. And a lot of times, if you think about it, like an organization is going to inherit a base organization, a base container image from something like Docker Hub, and that's completely okay. But at the same time, too, you need to then make it your own thing. Right. So again, like, maybe you're using Alpine, or maybe you're using one of the, maybe it's a distro with Nginx or whatever it may be. It's now basically given to your operational teams and your security teams to make sure that they put that layer on top of it. And then as part of that process, when they essentially make it their own, and I really kind of think of this as essentially like, it's very similar to build my own army. As part of building it, as part of my organization, or what my organization needs, so I can share it with my developers, that's when you need to think about the security scanning aspect of it, and make sure that it's instrumented throughout your pipeline, that it is compliant, and there are no essentially vulnerabilities with those images. So it's okay to have that access out there, but at the same time, too, your production builds shouldn't be trusting like just latest, of any container image, right? It's always supposed to be a versioned image that that you trust. And that's essentially how we talk about it when we talk about containers and pulling from public repos with our customers.
Okay. All right, great. We're about 4 minutes to the top of the hour. I think we have time for one more quick question, then we'll close it out. Can WhiteSource scan images in ECR registry built a long time ago on a daily basis to alert developers of a vulnerability discovery, or should images be rebuilt all the time to be scanned?
No, so what we do is essentially you can decide, but by default, we just take all the images in your ECR. So even if the images were built a long time ago, we can scan them. We use AWS APIs to actually pull the images and scan them automatically.
Okay, all right, great. Well, maybe we can hit one more quick question here. This is a good one. Is WhiteSource considered a DevSecOps tool?
So WhiteSource is a tool for everyone who's interested in compliance and security. We have a lot of our users who are working as traditional security officers. We have DevSecOps, we have developers, developer team leaders. So yes, it's definitely a tool for DevSecOps, but not only for them.
Okay. All right, great. Well, that unfortunately is all the time that we have for question and answers. So I'm going to have to close it out at this point. If we didn't get to your question, I apologize, but please know that that the folks at WhiteSource will be getting a copy of all of the questions. So Sherry or somebody from her organization, I'm sure, will be more than happy to follow up with you offline. And before we close things out, I do want to do our drawing for our 3 $50 Amazon gift cards. So without further ado, our first winner for the $50 Amazon gift card is Gary Johnson. Congratulations, Gary. Our second winner is Olu King. Congratulations, Olu. And our final winner for our drawing today is Christian Beans. Congratulations, Christian. I do want to remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to listen to it again, you will have the opportunity to do so. We will be sending out an email later today that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website. So you can always find it there. Just go to devops.com/webinars and look in the on demand section, and it should be right there waiting for you. I guess that's about it. Sherry and Carmen, thank you so much for your time today. Great presentation. I love demos. Demos are always so much fun to watch. So thanks very much.
Thank you.
Tons of good information there. And also want to thank the audience for joining me today for this great presentation. I'm Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.